We're going to go ahead and get the webinar started. Thank you so much for joining us today for the webinar, Customer 360, How Graph Visualizations Will Increase Customer Loyalty. We have two presenters for you today. We have Corey Lanham from Cambridge Intelligence and Brian Hall from Expero. At the end, we'll have about 10 minutes for questions, so feel free to leave them in the chat as we go along, and we'll be happy to get those answered for you. If you have any other questions, I will reach out at the end. If you have any, you can send me any questions you have if you have any one-offs. And with that, we'll go ahead and get started.
Okay, hello everybody. My name is Brian Hall. I'm with Expero. I run our graph practice, and co-presenting with me today is Corey Lanham from Cambridge Intelligence. Corey?
Hello, I'm Corey Lanham. I am the Commercial Director at Cambridge Intelligence. I'll be talking a bit more about the graph theory and graph visualization. Our product Keylines is used in some of the examples that we'll be showing today.
Okay. A little bit about Expero. We're a front-to-back consultancy, and we specialize in product innovation, bringing new ideas to the marketplace. One of the core technologies that we use frequently is graph databases, graph visualizations, and that consists of several aspects, including assessments, roadmaps, helping people figure out how to get the product to market, including but not limited to graph database product selection. So those of you out there trying to decide what graph technologies might be applicable for you, we actually do those sorts of product selection exercises. Next slide.
So I work for a company called Cambridge Intelligence. We're based in Cambridge in the United Kingdom. And we're about 5 years old and have been a visualization company focused on graphs. So what our aim is to expose end users and business users to graph technology. And we do so by having a JavaScript toolkit that we then license to our customers to embed inside their software applications to give that level of user interface and interactivity to graph data.
We at Expero have been doing graph and graph projects for several years now. We partner with several of the major graph database vendors on the back end. We also are members on both the Janus and Tinkerpop committee. And we've been working with the Cambridge Intelligence folks for a few years now. Next slide. Being in business for over 15 years, we've got a litany of customer references. Here's just a sample of our graph customers that we've done work with over the last 3 or 4 years. So let's dig into the problem at hand, Customer 360. Next slide, Corey. What exactly do we mean? Everybody's here to learn about it today, or you have some context, but just a level set. What do we really mean when we're talking about Customer 360? And that really means any number of the items here. You know, we want to know things about the customer, specifically demographic, their relationships to other entities, activity over time, what they've done with us and with other companies over history. What do they value and what do they not value, and any sorts of prompts or flags that may give us some context about their mood, what they're thinking, and how they're likely to behave going into the future. Next slide. So the good news here is that Customer 360 is not industry specific. You know, we run across this in our customer projects all the time. Healthcare, you know, complaints and who's going to refer who's going to refer patients for doctor to doctor. You'll see some of that today from Corey's demo. Financial services, you see this with respect to recommending products, upsell and cross-selling, customer complaints, and in the retail space, customer service, recommendation engines. In short, if you have a customer that you collect money from and they expect you to service them, then you've got a Customer 360 use case. A couple of interesting anecdotes here. One Bain & Company study suggests that even for satisfied customers, 60 to 80% of them do not rebuy from their vendors. You know, why is that? Are we not engaging them deep enough? Are we not proposing things to them that are attractive? That's for satisfied customers is quite surprising. A little less surprising, but probably more troublesome. 90% of dissatisfied customers don't complain before they leave you, and of those, only 22% are retained. So that's very emblematic of the customer churn problem. And as we all know, getting new customers is much harder than keeping the current ones. There's a Harvard Business Review study that suggests it's as much as 25 times more expensive to gather a new customer as it is to retain a current one. So as you think about your customer 360 issues, as you're looking for new prospects, do they have similarities to current customers? Can you use that for customer segmentation? Are they listening to your current customers? So are they influenced by people you're needing to service currently? What sorts of similarities can you deduce from your prospects to your current customers? So in short, as we look to gather data and begin to make inferences here, we're really looking to collect a couple of different things, really. So what are all the touch points that I've had with my customer? And sequence matters in this case, right? So have I had a series of interactions with them over time? Are they more frequent or less frequent? And then secondly, can I deduce anything from seeing how this customer is similar to another customer that maybe I've got a fuller picture on, right? So if my customer has gone through a sequence of events and other customers that have traveled that path before, they tend to be very lucrative customers, or they tend to leave me. I can deduce patterns based on the fact that they look from their series of interactions, they look like other paths that I've seen before. So once I know these things, I can begin to make all kinds of inferences that help me in my business. So customers that look like X tended to like Y, right? So that helps me with recommendation engines. That helps me compose campaigns where I might want to go engage deeper with my customers or propose new offerings. Customers that went through a sequence of events X are likely to do Y next. So that would suggest that I might be able to identify what we call a silent complainer, somebody that's unhappy that hasn't explicitly complained yet, and head off customer churn before it happens. Lastly, but not least, customers that have some sequence of events that may suggest that they're a bad actor teach us to be wary of subsequent potential bad actors, and that can help us in the anomaly and fraud detection space. Okay, so now that we've kind of framed the problem and the value to your business, let's talk a little bit about how we go about addressing that. So at Expero, we look at these graph projects from front to back, soup to nuts. From the far left, you see source data that could come from any of your systems of record, or maybe some social data that you're collecting. You've got to get that data in. You may collapse it down and do some processing before you get it into the graph engine in the center, the blue rectangle that you see there. Before it would get fed through the user interface, and Corey's going to show you how that gets fed to the customer here in a moment. But you need to deal with every layer of this data processing pipeline. Calling out one area in particular, as you collect the data, you oftentimes may do some entity resolution using string distance and collapsing down entities from different data sources, and possibly even some linear regressions to decide closeness, and is it more important for addresses to be similar than names or what have you, and you can use some machine learning algorithms to figure out these sorts of things. So in short, you can use your graph engine at the centerpiece here to become sort of a Rosetta Stone to pull together all of these disparate data sources over time and begin to make sense out of them and see patterns in your data. Okay, so
Okay, so
go
oh,
ahead. Go ahead, Corey. Sorry.
uh, what we're going to talk about in my section here is graph visualization and how that can be useful for identifying the relationships inside any customer activity data set. But I think it is helpful to take a step back and just review what a graph is and how it can be useful. So a graph is really just a model of the data that you collect every day. It's comprised of nodes and links. The nodes are objects, data elements such as your customers, for example, or the products that you're selling. And then the links are the relationships between those. So an order, for example, would be a relationship between a customer and a product for when they ordered that product. And each one of those can have properties. So the customer has properties like their demographic, their location, and things like that. The product has the properties associated with its price, other things like that. And then the relationship can also itself have its own properties. So for example, the order has a date and time when that order took place. It has a value or a dollar amount for the amount that was in the order itself, the amount that the customer may have paid for that product, for example. And graphs become really helpful when you care as much about those relationships and the interdependencies between those relationships as you do the actual data elements themselves. So not just looking at this specific customer or this subset of customers ordered these products, but when did those happen? What other customers had similar product orders? Or which other products had similar sorts of customers ordering from them? And the graph really helps identify those types of relationships very quickly and easily. So that explains why graphs are useful, but I think it's also helpful to go through very briefly why graph visualization itself is useful, because there may be cases where it helps to store the data in a graph model, but you don't necessarily need to understand visually how all of those things are connected to one another. So an example I like to use here is recommendation engines. In fact, Brian talked about that earlier. In many cases with recommendation engines, you want to provide your customer with, say, a list of other products that they might be interested in because their behavior is similar to similar customers and the products that they have bought. That can be very valuable for both you in selling more products and for the customer because they get access to things that they may not have known they wanted otherwise. But they don't need to see a visualization on how you got there or why they were recommended this particular product. They would just want to see what it is that they might be interested in. But in many cases, you are interested in showing those relationships visually. And it's really hard to think about a graph model that is comprised of nodes and links without at least mentally picturing those nodes as objects on a screen or a piece of paper and the links as lines drawn between them. So in this example animation that I have here on the right, we're showing, in this case, a set of individuals within an organization and how they're communicating between them. And the links are showing us those patterns of communication. And it's a very powerful way of understanding those types of patterns that you wouldn't otherwise see when stored in a tabular or any other type of typical business intelligence type application. So why might we want to use graphs? Well, it is intuitive. It really helps business users understand what they want to find in the data without having to have a degree in data science or understand how to query your data source or really need to know the data model for how it's stored. It's also very fast. You can make those intuitive observations quite easily compared to having to re-query a data source with different hypotheses and projects and things like that. It's also very flexible in that you can assign different graph models to different visualization models, depending on which pieces of information and which properties are important to you or to your users to help uncover those types of things. And it is insightful. You learn very interesting things very quickly in the data that you wouldn't otherwise see when you're working with data in other formats. But it is a matter of drilling down and looking at the data elements themselves. That's when graph visualization becomes useful. If you're not necessarily interested in, for example, what this particular customer did, or what this particular product is, how it's being, say, deployed throughout your organization, then graph visualization may not be the best way of approaching your large data sources. It may be better to look at charts and bar charts and pie charts and the more standard ways of modeling data because you're looking at data in the aggregate as opposed to in the individual cases. So we have a product called Keylines that I'll be showing you today. It is a JavaScript toolkit that enables you to embed a level of graph visualization into your web application. It's designed to be bound to any data source that has any sort of graph capability into it. Many times that is a graph database itself. So Brian talked a little bit about how they work with a number of different graph databases. And it's a natural fit to want to take data that you're already thinking of in terms of nodes and links and represent that in a visualization. But it's not necessarily a requirement. So many of our customers have a standard relational model with rows and columns and want to bind that to a visualization which represents that data as nodes and links. And you can see some of the examples here on the right. Our product itself is called Keylines. It's designed to be deployed across any browser and very quickly slotted into any web application, which has a requirement for end users to be able to visualize and analyze those data sources. It's a very quick and easy deployment that's designed to be able to bring those types of applications to the market and in front of those users much more quickly. And the customization piece is important too, because this allows you to bind or model visual properties of your graph to properties of the underlying data source. And that can be different depending on the type of data that you're working with. So for example, Brian talked about healthcare data. That's the example we're going to show you today, where we're looking at doctors and patients and the relationships between them and appointments and referral patterns and things like that. And I may have a very different set of properties which are relevant to show versus if I'm looking at a manufacturing scenario or a cybersecurity scenario, for example. So in this example, we took some healthcare data, we anonymized it, and we're looking at appointments for patients and doctors. Patients are seeing doctors via appointments, and then also referral patterns between doctors. So if the doctor thinks that somebody else is better suited to address whatever it is that I need addressed from a healthcare perspective, then they would refer me to somebody else. We have access to that data. And then facility data too. So many of these doctors work as part of a group or are employed by a hospital, for example, and it can be useful also to look at how those patterns arise in the facilities as well as the individual doctors. And what we're aiming to do is to really understand that customer feedback. So if we are a healthcare organization, for example, we want to understand why and when and under what circumstances our customers, who are our patients, are complaining, for example. We may want to understand and make sure that our doctors are doing referrals in network so that when the patient sees another doctor, for example, they're seeing somebody in our group. We may want to understand, for example, relationships between different doctors and facilities so that patients are being kept within the same facility when they're being referred or have additional appointments and things like that. We also want to understand those complaint patterns, because if somebody is say a serial complainer, then we might take their complaints as less of a mark on the doctor than somebody who has been seeing a doctor for decades and has a single complaint. That may be something worthy of further investigation. So we're going to use a number of different techniques in the graph visualization to help bring those patterns out and really understand them in a bit more detail here. So what I'm going to do is I'm going to leave the slides. And I'm going to bring up an example here. And this is a very common scenario when working with graph visualization. The temptation is to just take all of your data from your data source and dump it into a visualization. And oftentimes the result, if you don't really do much else in terms of helping narrow down the scope of what you're looking at, can be a little bit overwhelming. So this is all of our patient data, all of our appointment data, and the doctors and the facilities all in one view. And you can see some interesting patterns. So those individuals toward the center here are the most active. They're the ones with the most appointments. And the ones around the edges are perhaps less interesting to us. But it's not always the most useful to have a direct one-to-one correspondence between how your data is stored in your data set and how you want to represent it when you want to analyze and visualize that data. So in this case, in our graph database, the appointments themselves are nodes. You can see them here with the little clock icon. But we don't have very many properties of that. We just have a standard date time of when that appointment happened. And it's linked to the patient that had that appointment and to the doctor as well. So what we're going to do is we're going to take a different model of the data and present that to the users, where the appointments are actually going to be modeled as links between the doctor and the patient. So that's the first step here, and that's going to clean up the example a little bit. So you can see now that the appointment nodes have disappeared. It's a little bit easier to understand, but there's still a large number of links on the chart. And that's because we have each appointment modeled as a separate link. So for example, when a doctor sees a patient, many times over the course of a possibly years-long relationship, then we see a number of different links, perhaps dozens of links between that patient and that doctor. That may be not particularly helpful for us. We want to understand more directly what is the relationship between this patient and this doctor, not each individual instance in which they were seen. So what I'm going to do here is I'm going to merge the links so that the relationship is represented by a single link, even if it represents multiple appointments. The other thing I've done is I've taken the width of the link and bound that to the number of relationships between those two individuals. So the thick links are showing me people who have a very strong connection, either multiple appointments or lots of referrals, for example. And the thinner links are showing me fewer. I talked a little bit earlier about how it's helpful to use visual properties to identify properties in the data source. What I'm going to do here is I'm going to use the size of the node to show me the number of relationships. So the doctors will be scaled by the number of links that they have, both to other doctors and to the patients, and the patients themselves will be sized based on the number of appointments that they have, so that we can identify those large volumes of data that we want to pay a bit more close attention to. So in those various steps that we've gone through, we've taken what is a very busy and hard to understand chart and really boiled it down to something that makes a bit more sense. We see the doctors in the center here. They're scaled by the amount that they're represented in our data. We see the individuals that are patients linked to the various doctors that they may be seeing, and we can learn a bit more about it. So now we're going to run a layout. A layout just changes the physical organization of those nodes on the chart. And there are many different layouts that you can apply based on what it is that you want to gain out of it. In this case, we're just trying to increase the readability. So we're not changing the underlying data source. We're just changing how it's displayed to make it a bit easier to understand. And the other thing we've done is we've added the Keylines time bar at the bottom of the chart here. So as I mentioned, each appointment is a link between a doctor and a patient. Each appointment takes place at a specific point in time. And so we've taken that data, which in our case happens to cover the year 2017, and shown that at the bottom here with the histograms indicating the volume of patients, of appointments that took place during each month. The nice thing is that we can now understand both patterns in terms of who's connected to whom else, but also in terms of when those connections may have happened. So for example, if I highlight August in the time bar, I've brought to the foreground in my Keylines chart only the appointments that happened in August, for example. So I can watch the evolution of how these things are changing over time. The other thing that is really important with graph visualizations is the ability to filter or search through the data so that you can understand subsets of it and not have to look at the whole thing all at once. So for example, what I did here was I created the ability to search for an individual. So if I type, say, Z-A-C-H, I've got a single doctor whose name is Zachary, and I've got him on the chart. When I select him, I'm filtering out, I'm eliminating from my graph everybody else except for both the doctors that are connected to him via referrals and the patients that he has seen. So you're very quickly able to drill down from an overall view of everything in your chart or of everything in your data source to the individual that you are interested in learning a bit more about. So that works when I zoom in on a doctor. I can do the exact same thing when I wanted to focus, say, for example, on a patient. I have somebody named Allison here who I've highlighted, and Allison has had appointments with these 4 doctors. I talked about various properties of the nodes and the links. So in this instance, what I've chosen to do is to show you those properties over there in a pane outside of the graph visualization. That can be really helpful because I may not necessarily care, and it would clutter up the chart quite a bit to see Allison's date of birth and her phone numbers, for example, on the chart. But removed from it, when I select her, that information can be much more interesting to me and much more valuable. I also talked a little bit about how we have properties on the links. So what I'm going to do here is I'm going to select 2 doctors and the link between them. So Zachary and Michaela have a referral relationship between them, and we can see exactly when those referrals are happening. So we can see the volume of referrals in each month of 2017 as they happen. So I can identify something much more interesting has happened in March and in August compared to the other months. Why is that? I can drill down a bit more and find out a bit more data about that. Similarly, with the link between a patient and a doctor, I can find out exactly when those appointments happened. If they were in rapid succession, that means something different than if they were spread out across various years. And I talked a little bit about complaints earlier too. It can be helpful to show those on the chart. So right now, previously, I was showing every link between a patient as a doctor and a doctor as an appointment, some of those which had complaints associated with them and some of which didn't. What I've done here is I've shown those visually on the chart differently. So the ones that have complaints are in red, and the number of complaints is highlighted as a glyph on the link, giving a little bit more information that stands out on the chart in that example. So for example, here, I can look at the relationship between this doctor and this patient. I'm sorry, I didn't click on the right thing, and I can see, for example, that there was an appointment there on April 14th where there was a complaint. Now, given the pattern of complaints, I may want to take a more close look at, say, for example, as a doctor receiving an inordinate number of complaints, something that I have to investigate are those complaints all clustered around a specific point in time versus being spread out over the course of a year or something like that. So the thing that stands out here is that Jose Garcia, one of our doctors, has a larger number of complaints associated with him than any of the other doctors. But we can also see that 3 of them come from one patient, Rachel Jackson, who has also complained about other doctors as well. So it may be the case that she just likes to complain and isn't necessarily, there's not a quality problem associated with that doctor. So by taking what is an unorganized set of graph data, representing it in a chart like this, you can really get some very quick insights into different patterns, both patterns over time, patterns over the connections that you may want to investigate further. And certain things like, for example, the pattern of complaints that we see stand out visually. You don't have to really understand the model of the data or even know what you should be looking for in order to be able to make those inferences and come up with ideas of what you need to look at. But even this data set is a bit busy. There's quite a bit of data that we're looking at all at once. So what we focused on with Keylines is a way to do what we call combinations, which is a way of grouping sets of data elements together and showing how those groups themselves are connected to one another. It simplifies the view. It gives you an overview of the data and then allows you to drill down to the subsets, the data elements that make sense depending on your workflow. So what I'm going to do now, we've ignored the facilities until now, but each doctor works for a facility. So I'm going to group my providers based on the facility that they work in. So now I have a node on the chart which represents the facility that these doctors work in. And each one of those is combined into a single node representation. And we can see all of the patients seen by any doctor in that facility. So I get an overview or a very simplified view of this chart. But I can still get the detail when I want to. So for example, if I want to drill down into this subset, there are the 4 doctors in the facility associated with that group and see who they're connected with. So for example, when I select inside of that subset of the data, Tegan Alexander, I can see who he is connected to, which patients, which other facilities, and which other doctors he's referring to. The benefit of this is that, as I mentioned right at the beginning of this example, it's very tempting to just throw all of your data into a single graph visualization, and then you get overwhelmed. There's just too much to focus on, and it's not easy to draw out any patterns or inferences that you can make from it. But by using some of these techniques, the filtering by time, the grouping, the filtering out of the chart, the sending things to the foreground versus the background, like you see I've done here, all of those really help to the end user who has to make business decisions based on this data, focus on the bits that are relevant to them without losing the context of everything else on the chart. So that's it for the demo. I'm going to just jump back to the chart, to the slides now. And I think that we are actually complete. So what we can do now is hand it back over to the Expero folks to take any questions.
Yep, thank you guys so much. We do have one question here. Is there a WebGL full support?
In our product, there is. In fact, Keylines is built from the bottom up to support WebGL, and the demo I showed you today was using WebGL.
Perfect. And then we have another question. Do you need a graph database for this?
Okay, I talked a little bit about that right at the beginning, but many of our customers do use a graph database, and it makes it quite easy because you're already modeling your data in terms of nodes and links. But it's certainly not a requirement for Keylines itself. We have plenty of customers who have modeled it to either relational databases or even just key value stores like Mongo. There's a bit of modeling work that you have to do to get that to work, but it is supported.
Okay, thank you. And then the final question, is there a way to visualize a graph overlaid on a map?
There is. I didn't show that today because we didn't have location data with the sample data that we used in this example. But when you do have location data, it can be very helpful to show graphs superimposed over the top of a map to see any patterns in space, as well as time, for example, with the time bar and the actual link chart itself. This can be very helpful if you have data that lends itself very well to being organized over the top of a map, but you do lose layout flexibility. So I talked a little bit about layouts and how physically organizing where things are on the screen without changing the underlying data can be really helpful to expose different patterns in it. When everything's put on a map, you don't have that flexibility anymore because they have to sit on the map where they belong. And as a result, you can get a little bit of clutter and it makes it a little bit more difficult to understand. But in many cases, it is useful.
I would also add, Corey, that there are a handful of geospatial examples on the Expero website. So that is possible and applicable in some instances, particularly when you're talking about logistics, supply chains, those sorts of use cases.
And do you provide out-of-the-box clustering features?
I'm not sure if that question was for me or for Brian, but I'll answer first. We do have a cluster. Our product is an API, so really you could either say everything's out of the box or nothing's out of the box. But we do have some clustering functions built into our API that our users can take advantage of.
And to further color Corey's comment, many of the graph engines that we work with have clustering algorithms built in as APOCs if you're talking about Neo4j, or built into the Tinkerpop API with some of the more sophisticated recipes.
Okay, and one final question here. What kind of math algorithm exists in the box?
Okay, so we have a number of different algorithms in Keylines for doing different types of graph analytics. And much of that depends on the type of data that you're working with and what you're aiming to uncover from it. So we have things like PageRank, which shows you what the most highly connected or well-connected nodes are in the chart, or something like betweenness, which will help identify which nodes are acting as conduits, which ones are holding the whole graph together, where if you deleted them, then the graph would be split into various pieces. And so there's about maybe 10 or so of those types of algorithms that we support natively in Keylines. But because it's an API, there's no limit to, if you have a different algorithm that we don't natively support, you could implement it directly on our API.
Again, to color that question, we end up doing a lot of back-end analytics in order to pre-compute some of those sorts of things using Spark batch jobs, if you will, or again, APOCs if you're in the Neo world.
Okay, and is there any technical limit to how many objects can be shown on a graph?
There definitely is a technical limit, but I've found that you hit the limit of what's really usable or makes sense well before you hit any sort of technical limit. So I've personally created graphs with tens of thousands of nodes, all visible at the same time, but you run out of pixels on the screen well before that point. So really, I think the value comes from when you start to boil down a large data set. You can do some pre-processing on the back end, such that Brian's talking about. And then even once you do get into the graph, if it's more than a few thousand nodes, then you want to have a lot of capability on how to run those filtering, the clustering, the grouping, and things like that to get it to a size that actually makes it usable.
And we also at Expero have a fair amount of user research that suggests that the human limits of what people can process visually is hit way before you would hit technical limits about what you can present in the screen. There's a human factors notion of dominant dimensions where you might want to scan through a large data set before you actually presented the details on demand.
Okay, and do you have capabilities to get visual properties such as graph density?
Again, I'm not sure if that question was for me, but I'll go first. We do have, I talked a little bit about how the visual properties themselves can be bound to properties of the data source. There are also algorithms within Keylines that can take a look at the data, including the visual properties that you've set, and run algorithms on that. There are certain circumstances where you may want to use that, but in many cases, it makes more sense to look at the underlying data itself.
Okay, and we do have one final question here, and then I will go ahead and put my contact information in the chat right here so that if you want a copy of the webinar recording, I'm happy to send that. Also, if you have any additional questions, we can get those answered for you via email. The last question is, do you find that users are able to easily grasp how to use and navigate a graph-based interface, or is training often required?
I would say that the whole point of doing graph visualization is that it is a very intuitive user interface. So we don't often find that the actual interaction with the graph is something that has to be trained. That's something that just sort of comes naturally. People draw on whiteboards nodes and links and relationships between them all the time. However, if you do add in some sophisticated analytics, such as some of the graph algorithms that I talked about a bit earlier, then yes, you would want to explain to the business users what those mean, how they're calculated, and what you would do with that information. So as it gets more complex, training becomes more important.
Yeah, and I would, to further color that, in the projects that we undertake, in very few, if any, cases are you singularly navigating through a graph and a node chart. Usually complex applications would have a mixture of, imagine a recommendation engine where the recommendations might spit out in a tabular form. I'd, recommend you buy this book and this CD and what have you. So that might come out as a table, juxtaposed perhaps under some circumstances next to a node chart, right? So as you get multiple visualization types and how they might interact with each other, that tends to mean that some training may be required.
Great. Well, thank you all so much for joining the webinar today. Like I said, I will be sending out an email once we have the recording finished with a copy of it. If you want to reach out for any questions, please feel free to contact us on any of the emails provided here on this last slide. And also, I left my contact information in the chat. Thank you again, and have a great rest of your day.